Good evening, students. How are you? This is Ankit Joshi. I welcome you all on India's largest e-learning platform, BYJU'S Exam Prep. Students, this is our YouTube channel for EC, Electrical, Instrumentation and Computer Science. And this particular session is very useful for all branches of engineering except computer science. So students, stay tuned for the entire concept of partial differential equation. As I promised few days before that I will be taking up this topic separately on YouTube. So yes, this is scheduled in order to fulfill that promise. I can see Raghuram in the comment box. Welcome to the session. Raghu, how are you? Am I audible to all of you? I can see Raghuram, Yashwant, Prathamesh. Good evening, everyone. That's great, Raghu. Let's proceed. So students, this is the brief profile about me. I have been teaching in this GATE and ESC domain since many years, and my subjects of interest are engineering mathematics, signals and system, and analog circuits. So engineering mathematics, very important topic, partial differential equation that we are going to cover here. Student, before me moving ahead, I want to just announce that your favorite Rakesh Talreja sir will be taking a workshop on 29th Jan at 12:30 afternoon. And yes, this workshop will be on our app, BYJU'S Exam Prep's app. I will show you the entire schedule. See, now you can see the entire slide. Rakesh sir will be taking up this particular session on 29th of Jan, 12:30 in the afternoon. Okay? Yes. And this is focused for, this is targeted for GATE 2024 candidates and students. We just request you to share this information with your juniors. So students, when we talk about partial differential equations, listen carefully what happens. See, if you have a dependent variable z, which is the function of more than one independent variables. If dependent variable z is the function of more than one independent variables, then what happens? Partial derivatives will exist. See, z कितने वेरिएबल का फंक्शन है? Z is the function of two variables. So z is the dependent variable and x and y are the independent variables. So we can say that z is the function of two independent variables. So when z is the function of more than one independent variable, partial derivatives will exist. Okay, when you have the dependent variable function of single independent variable, then simple derivative will exist. So currently I am saying that z is the function of two independent variables, so partial derivatives will exist. So how can you denote the partial derivative? Del z by del x. This is partial derivative of z with respect to x. Then del z by del y. This is partial derivative of z with respect to y. So these two partial derivatives will exist. Comfortable with this? All of you comfortable with this? Del z by del x and del z by del y, this will exist as partial derivative. Understood? Comfortable with this? Now, in this situation, when we talk about a differential equation in which dependent variable involved is z, listen carefully. What is differential equation? Differential equation involves dependent variable, independent variable, and the derivative terms. Dependent variable, independent variable, and derivative terms. So if the dependent variable involved is the function of more than one independent variables, then partial derivatives will be seen in the differential equation. Then such a differential equation will be called as partial differential equation. A differential equation in which dependent variable is the function of more than one independent variables, then partial derivatives will appear in the differential equation. Such a differential equation can be called as partial differential equation. See here. See here. If the dependent variable involved in the differential equation is a function of more than one independent variables, then partial derivatives will appear in the differential equation. Okay. Then such a differential equation will be referred as partial differential equation. Is that very clear? All of you got the meaning of partial differential equation? Okay. Here the dependent variable is the function of more than one independent variable. That's why partial derivatives are appearing in the differential equation. Okay, sir. Now, further moving ahead, partial differential equations are of two types. First order partial differential equation, and second order partial differential equation. First order and higher order you can say. So partial differential equations are of two types. First order partial differential equation, and then we have higher order or second order partial differential equation. Is that clear? Now let's move ahead. See, we are currently talking about first order differential equation. Listen carefully. See, if z is the dependent variable, which is the function of two independent variables x and y. If z is the dependent variable which is the function of two independent variables x and y, then we can definitely say that two partial derivatives del z by del x and del z by del y will exist. Very good. These two partial derivatives will exist. Now, del z by del x is having a universal notation. Del z by del x is denoted by P, and del z by del y is generally denoted by Q. Okay, so when we talk about first order partial differential equations, then our partial differential equation will be containing P and Q. What is P? P is del z by del x and Q is del z by del y. As far as the order of the derivative is concerned, both these derivatives are first order, and hence this differential equation is called as first order partial differential equation. Comfortable? So if the differential equation's order is first order, it will be called as, if the differential equation is having first order partial derivatives, it will be called as first order P.D.E. If the differential equation is involving first order partial derivatives, it will be called as first order partial differential equation. Okay, yes, you can just have a look over this. I'll just hide myself. See, consider a function z which is f of xy. P is del z by del x, Q is del z by del y. Partial derivatives P and Q will exist. A partial differential equation which involves first order partial derivatives, that is P and Q only, is called as first order partial differential equation. Now, as we recently defined first order partial differential equations, first order partial differential equations are further classified as first order linear and first order non-linear. Comfortable? Now I will explain what is linear and what is non-linear, and then we'll solve the various types. See here, students. As we all know that first order partial differential equation means it can have P and Q only. The derivatives only P and Q will be there. Comfortable? As far as derivative is concerned, only P and Q will be there. P is del Z by del X, Q is del Z by del Y. Now, why this is called as linear, or under what circumstances it will be called as linear? Listen carefully. Degree of P and Q is 1 and they are not multiplied together. Degree of P and Q is 1 and they are not multiplied together. P और Q का डिग्री 1 होगा और ये टर्म्स आपस में मल्टीप्लाई नहीं होंगी. If in the differential equation degree of P and Q is 1 and they are not multiplied together, then it will be called as first order linear P.D.E. In a first order linear P.D.E, P and Q occurs in degree 1. P and Q occurs in degree 1 and they are not multiplied together. P and Q occurs in degree 1 and they are not multiplied together. P and Q occurs in degree 1 and they are not multiplied together. First order linear P.D.E is also called as Lagrange's partial differential equation. So this heading first order linear is also known by the name Lagrange's, because Lagrange was the mathematician who proposed this differential equation. So on your screen you can see this is the general format for Lagrange's differential equation. And what is Lagrange's differential equation? It is first order linear. Listen carefully. So when we talk about first order linear P.D.E, its format is P.P Q equal to R. Now you may be thinking, what is capital P, Q and R? So capital P, Q and R, they are the mixed functions of X, Y and Z. Capital P, Q, R are the mixed of X, Y and Z. Comfortable? Now, in order to solve this Lagrange's equation, what we need to do? इस Lagrange's equation को solve करने के लिए हमें क्या करना होता है? So first of all, we need to write the auxiliary equation. Sir, what is the general format for auxiliary equation? It is dx upon capital P, y upon capital Q and dz upon capital R. Okay. In this auxiliary equation, how many terms you can see? कितनी terms आप देख पा रहे हैं? I can see three terms. We will consider two at a time. Either first and second, or second and third, or first and third. We will consider two at a time and solve it to get one solution. Okay. Let us say one solution is U. Then we will consider another two and solve them to find the another solution V equal to B. Okay. This auxiliary equation has got three terms. We will consider two at a time, solve them to get the one solution U. Then we will consider another two and solve them and get another solution V. Finally, you need to club U and V together. This is your complete solution. ये होगा complete solution. Okay. So this is how we approach for Lagrange's partial differential equation. Comfortable? Let's move. See this question. We want to solve this partial differential equation. Now see here. In this differential equation, which all derivatives are present? Apart from Natu and Raghuram, who all are there? They can also comment. They show your presence in the comment box. Others, all my favorite students, all my dear students, you should show your presence in the comment box. It's not only about one or two students. Yes, that's great. Prathamesh is there, Gopi Chand is there. All of you, Amit Singh. Yes. Self-dependent is also there. Vitri, how are you, Vitri? Vitri Surya, Vitri from Chennai. Fazil Bhai. So students, all of you must show your presence in the comment box. Thanks for listening me. Thanks for following me. So students, जरा एक बार सेशन को लाइक कर दिया जाए. Let us hit the like button. Okay. Yeah. So let's proceed. Students, in this differential equation, first identify the format. Which derivative terms are there? Sir, only first order derivatives are there. Only first order derivative terms are there. Victory, I am also fine, beta. Wish you best of luck. Students, in this differential equation, only two derivative terms, P and Q. Both are first order derivatives. P and Q both are first order derivatives. What is the degree of P and Q? Sir, 1. Are they multiplied together? No. So students, we can say that this differential equation has P and Q which is occurring in degree 1 and they are not multiplied together. So this differential equation is a first order linear differential equation. This is a first order linear. This is a first order linear partial differential equation. Now this partial differential equation was proposed by Lagrange's. So this is also called as Lagrange's partial differential equation. Now students, we will compare this with the exact format of Lagrange's. P plus QQ equal to R. Compare कीजिए. What you will get? You will get P. What is P? P is capital P is the coefficient of small p. Capital Q is the coefficient of small q. Then right hand side is nothing but R. Comfortable till this point? Now after this we will be writing the auxiliary equation. Auxiliary equation is also known by the name subsidiary equation. Auxiliary equation and subsidiary equation, one and the same thing. So auxiliary equation, what is the format? Dx upon P, dy upon Q and dz upon R. P कितना है भाई? P is 1, Q is -1, dz upon R is log x plus y. So this is my equation number 1. Now we will consider two ratios at a time. मैंने consider किया first and second. Now I will consider first and second ratio. From equation 1, I am considering first and second ratio. Dx by 1 and dy by -1. Dx by 1 and dy by -1. Okay. Now what can be done, beta? Now this can be written as dx minus dy. Dx minus dy. And which can be further written as dx plus dy equal to 0. Can we integrate both sides? Can we integrate both sides now? Can you all integrate this? Integrate both sides. Integrate both sides. So integration of dx will be x. Integration of y will be y. Integration of y will be y. And since the integration is done, integration of 0 is 0, but you need to add some constant here. So I am adding a constant a. I am adding a constant a. So students, this is our first solution. We have to denote it by our usual notation u. So I am denoting this by u, which is x plus y equal to a. So all my dear students, all my sincere students, all future engineers, yeah. So students, see here, this is the first solution. This is my equation number 2. Now I will consider another two equations. Now I will consider another two equation from equation, another two ratios from equation 1. So this time I am considering either second and third or first and third. Second and third भी ले सकते हैं, first and third भी ले सकते हैं. Yes, Mitri, we will consider first and third for simplification. So to get the second solution, I will consider first and third ratio dz upon log x plus y. Comfortable बच्चा लोग? Now please students concentrate here. In order to simplify this further, I will take the help of the first solution. I will just hide myself and show you the first solution once again. See, student, left hand side has got no problem here. Dx is okay. But see, right hand side dz upon log, and this x plus y is a constant. So I can replace it by that constant a. हम उसको constant से replace कर सकते हैं. Log x plus y is log a. Now integrate both sides. So integration of dx will be x. 1 upon log a is a constant term that will move out of the integration, and integration of dz will be z plus some constant b. Okay. So students, bring this second term on the left hand side, minus z upon log a. And what is the value of a? Value of a is x plus y. Value of a is x plus y. Okay. So student, this is our second solution. Second solution is denoted by v. Second solution is denoted by v. Second solution is denoted by v. So we have got one solution in equation 2, another solution in equation 3. Understood? Now we will club these solutions together. अब हम इन दोनों सॉल्यूशन एक साथ लिख देंगे. So students, complete solution is given by phi of u comma v equal to 0. Now what is u? Don't write the constant part, only write the variable part, x plus y. Now what is v? This portion is v, x minus z upon log x plus y. X minus z upon log x plus y. So बच्चा लोग, this is the required solution. और last में, in the last, right is the required solution with pride. Okay. So this is how this Lagrange's differential equation is solved. This is how Lagrange's differential equation is solved. Understood, students? Now see this. In this particular question, in order to maintain the symmetry on both sides, I am just multiplying by x throughout the equation. Yes, Fazil, thank you. I am just multiplying by x throughout the equation. पूरे equation में x से multiply कर दिया. So you will get what? Y square z into p, then x square z into q, and on right hand side you have x y square. Comfortable? So clearly we can say that here the derivative terms are only p and q, which are the first order derivatives, and first order derivative terms are having degree 1. p और q का power 1 है. p and q occurs in degree 1 and they are not multiplied together. p and q are not multiplied together. P and Q occurs in degree 1, so it is first order linear PDE. First order linear PDE. First order linear PDE means Lagrange's PDE. Okay, it is Lagrange's PDE. So what we will do, we'll write the auxiliary equation now. So what is the format for auxiliary equation? Tell me, students. Dx by P, dy by Q, and dz by R. Okay, yes sir. So Lagrange's PDE is PP plus QQ equal to R. You can compare and find out the value of P, Q and R. You can compare and find out the value of P, Q and R. Dx upon P, P, capital P is the coefficient of small p, y square z. Dy upon Q, capital Q is the coefficient of small q. क्या होगा? What it will be? Sir, x square z equal to dz upon r. R is this right hand side function. Great. Great, sir. We understood till this point. How many of you understood this Lagrange's auxiliary equation? Now we will consider two ratios at a time. Consider two ratios at a time. So I am considering first and second, y square z p, x square z q, c, x y square on the right hand side. Great. If I consider first and third, will it work? If I consider first and second, then what? Then also it will work. So I am considering first two. सबसे पहले मैं ले रहा हूँ first two ratios, dx upon y square z and dy upon x square z. Comfortable with this? Dx upon y square z and dy upon x square z. Now see here, we can strike out this z both sides. There. Separate the variables. X square dx equal to y square dy. X square dx minus y square dy equal to 0. Integrate both sides. Integrate both sides. You will get x cube by 3 minus y cube by 3 equal to some constant, say c1. So students, what we are doing, x cube minus y cube equal to 3c1. Now we are just replacing this 3c1 by a new constant a. So this is our first solution. I hope this is very much clear to all of you. Now we'll consider another two ratios to get the second solution. Now we'll consider another two ratios. Now fine. Okay. So it was a little bit technical glitch, maybe due to internet or maybe due to the server. So I hope, is it all fine now? Once again, yes. Now fine. Ashraf Khan will get back to you. So students, Chaliye, see here. What you can do now, you can cancel y square on both sides. So what is remaining? X dx equal to z dz. Bring all the terms on the left hand side. X dx minus z dz equal to 0. So students, once you integrate this, what you will get? X square by 2 minus z square by 2 equal to, say, another constant c1. So x square minus z square equal to 2c1, and we are just replacing this 2c1 by another constant b. So this is another solution v. Okay, yes sir. So this is our fourth equation. So I hope you got the solution now. We'll just write the complete solution. Complete solution is phi of u comma v equal to 0. U, x cube minus y cube. V is x square minus z square. This is the required solution. This is the required solution. Comfortable, students? No. Next, we are moving towards the non-linear format. First order non-linear partial differential equation. First order non-linear partial differential equation. So student, under what circumstances an equation will be called as non-linear P.D.E? Under what circumstances an equation is called as non-linear P.D.E? Students, since it is first order, it will contain P and Q only. But degree of P and Q is other than 1, or they may be multiplied together. P और Q का डिग्री 1 से हटके कुछ और होगा, या ये टर्म्स आपस में मल्टीप्लाई होगी. The degree of P and Q is other than 1, or they are multiplied together. Then it will be called as first order non-linear P.D.E. So first order non-linear P.D.E means the degree of P and Q is other than 1, or they are multiplied together. Now, when we talk about non-linear first order P.D.E, there are 4 possibilities, 4 cases. Before that, I just want to tell you which all parameters can be there in a first order non-linear partial differential equation. First order non-linear partial differential equation में क्या क्या हो सकता है? Which all parameters can be there? So students, there can be z, independent variables x and y, and first order partial derivatives p and q. So these 5 parameters are part of non-linear. These 5 parameters will be part of non-linear P.D.E. Okay. So depending on the content out of these 5, which parameters are present in the differential equation, we have got 4 different cases. When we talk about type 1, first order non-linear P.D.E, type 1. Out of these 5 parameters, In type 1, equation is containing only P and Q. Out of these 5 parameters, the equation is containing only P and Q. If equation is having only P and Q, then equation's format will be like this: f of P comma Q equal to 0. And if your equation belongs to type 1, then its general solution is will be what is the general solution? General solution will be z equal to ax plus by plus c. Student, as soon as you identify that it is type 1, non-linear PDE, then you can straight away write its solution. Solution is z equal to ax plus by plus c. Fix है, it is fixed. Now the interesting part is a and b are related with each other. What is interesting part here? A and B are related with each other. So students, this A and B are connected by the same relation by which P and Q are connected. So f of P comma Q equal to 0. Replace P by A, replace Q by B. You will get one more relation, but this time in terms of A and B. So this relation is relating arbitrary constants A and B. You can find out B in terms of A or A in terms of B and replace any one arbitrary constant here in the general solution. Okay? Yes. Sir, once again, see here. In type 1, the differential equation will have only P and Q. Of course, it should be non-linear, huh? It should be non-linear. The differential equation will have only P and Q. So as soon as you identify that it is type 1 non-linear first order PDE, you can write its general solution straight away as z equal to ax plus by plus c. Now, a and b are related with each other. How a and b are related? A and b are related by this relation. So f of a comma b equal to 0. Okay. So students, are you enjoying? Chal. See this. In this differential equation, only P and Q are there. P and Q are there. But so only P and Q are there, it means it is first order. Only P and Q are there, it means it is first order. But P appears in a degree 2. So this is non-linear. So this is non-linear first order PDE. Now, there can be 5 parameters z, x, y, p, q. This contains only P and Q. So this is type 1. Okay. In type 1, just find out f of P comma Q equal to 0. This is the format of type 1. Yes, sir. So here we can write this as 3p square minus q equal to 0. Okay. So 3p square minus q equal to 0. So this is type 1. This is type 1. आवाज कीजिए. So its general solution is z equal to ax plus by plus c. Okay. Also a and b are related with each other. A and b are related by this relation. So in this relation, just replace p by a, q by b. So what is b? b क्या हुआ बच्चों? b is 3a square. Put this in equation 1. So finally equation 1 is giving you ax plus 3a square y plus c. Yes, sir. So this is the required solution. I hope you understood. Students, Direct 1 mark, 2 mark question can be asked on this variety. As per the past experience, I am saying this. Next, now see here. This equation is also having only P and Q. Students, I need response from all of you. Everyone should respond. Students, this equation is having only P and Q. Of course, Rupesh, for all branches of engineering, except computer science. Except computer science, all branches of engineering. Now see here. In this equation, P and Q are present. So this is first order. This is first order. Yes, sir. But P and Q appears in a degree other than 1. So this is first order nonlinear. First order nonlinear P.D.E. Now, it contains only P and Q. There are 5 parameters. There are 5 parameters. There are 5 parameters. Z, X, Y, P, Q. It contains only P and Q. So this is type 1. Okay, Sarji. Type 1. Type 1 format is f of P, Q equal to 0. So bring all the terms to the left hand side. सब के सब को left hand side पर लेकर आओ. All should be brought to the left hand side. So clearly I can have the solution now. General solution. General solution. General solution will be z equal to ax plus by plus c. Okay, sir. Now we also know that f of a comma b equal to 0. So in this relation, root a plus root b minus 1 equal to 0. So root b equal to 1 minus root a. Root b equal to 1 minus root a. So squaring both sides, you will get 1 minus root a whole square. You can put this in equation 1. You can put this in equation 1. So equation 1 is finally giving us the general solution. Ax plus by. What is b? B is 1 minus root a whole square. This is the required solution. This is the required solution. This is the required solution. So you can clearly observe here that the solution of nonlinear P.D.E. is containing 2 arbitrary constants only. So the format is having three constants. This format is having 3 constants A, B, C. But we are replacing B in terms of A. So ultimately the final answer is having only 2 arbitrary constants. Remember this. This can also be a question. Now type 2. In type 2, one more parameter is introduced. P and Q were already there. We introduced Z also. P and Q were already there. We introduced Z also. Okay, sir. Now, what you have to do in this equation? In this equation, you have to put P. You have to put P equal to dz by dt and Q equal to a dz by dt. Okay, you have to substitute P equal to dz by dt and Q equal to a dz by dt. Okay, once you substitute this, once you do this, what you will get? You will be getting a simple differential equation in Z and T. You will be getting a simple differential equation in Z and T. Okay, so students, here अरे यार, what is t? T is equal to x plus ay. Wherever you have t, finally you can replace t by x plus. Wherever you have t, that t should be replaced by x plus ay. Okay. Good evening, Satvika. How are you? Next, Nasir. Students, in this differential equation, you have p, q, and z. Okay. Listen carefully. As far as derivative terms are concerned, only first order derivatives are there. This is first order equation. Now see here, P is multiplied with this Q. PQ multiplied together. PQ multiplied together. So this is non-linear. Non-linear first order P.D.E. But this is having three parameters. P, Q and Z. P, Q and Z are there. So this is type 2. Type 2. Type 2 का format क्या है? Format of type 2 is function of f, comma z, comma p, comma q equal to 0. What is the working rule? Working rule is p equal to dz by dt and q equal to a dz by dt. This you need to put in given equation. This you need to put in given equation. Put in given equation. Equation number 1. Equation number 1. P is dz by dt. 1 plus q is a dz by dt. Right hand side q is a dz by dt multiplied by z. Okay, so student, I am just striking this dz by dt both sides. हम दोनों तरफ dz by dt को शहीद कर देंगे. ये गया. टन टन. हाँ. So what is left now? It is 1 plus, okay, separate the variables बच्चे लोग. A dz by dt equal to az minus 1. Now dz upon az minus 1 equal to dt. Variables are separated. Integrate both sides. So a is out. dz upon az minus 1. A is out. dz upon az minus 1 equal to dt. Now integrate this. What you will get? Log az minus 1 divided by derivative of az minus 1 will be a. Integration dt will be t plus some constant that will be c. Okay, sir. A cancelled. So log az minus 1. And students, remember that this t is x plus ay, a linear combination of x and y. And as I already said that the solution will contain only two arbitrary constants. So here also you can see two arbitrary constants, a and c. This is the required solution. So I hope you would have understood how to approach for type 2. Yes, identification part is really very important. I need response from all of you. All means all. Now, this equation is containing P and Q, but the degree of P and Q is other than 1. So this is non-linear first order P.D.E. As far as the perimeters are concerned, only 3 parameters are there, P, Q and Z. So this is again type 2. So I just request all of you, can you solve this? So I'm just keeping this as the homework for you. Okay, so just you need to put P equal to dz by dt and Q equal to a dz by dt. Simplify and proceed. Okay, yes. So this is the homework for you. I believe every one of you can do this. How many of you need the PDF? Join my Telegram group to get the PDF of this. Now see here, type 3, type 3, type 3, type 3. In first order nonlinear PDE, type 3. In type 3, students, there will be 4 parameters: X, Y, P and Q. Z is not there. Out of 5 parameters, 4 are there: X, Y, P and Q. But this is of special type. This is of special type. Means terms containing X and P can be separated on one side, and terms containing Q and Y can be collected on other side. Wow! Terms containing X and P can be separated on one side. Terms containing Y and Q can be separated on another side. If you are able to do so, if you are able to do it, this is just denoted by, this is just equated by some constant k. Okay. Now what we will do, what we can do here, we can just consider f of x comma p equal to k, and then we will equate this also to k. Okay, from here find p, from here find q. चलिए फटाफट रिस्पॉन्ड कीजिए. After getting the value of p and q, what you need to do? There is a formula to solve this type of PDE. What is that formula? See here. Solution is z equal to integration p dx plus integration q dy plus c. This is the formula to solve. This is the formula to solve this type. This is the differential equation, first order non-linear PDE, and this is the formula to solve. Yes, come on here, hit the like button if you have not done so. Chaliye, next. Students, before this, one announcement for you, that All India Open Mega Mock Test for GATE 2023 aspirants, that is scheduled between 24th Jan to 30th Jan. You can register for it, and yes, this is on our app, BYJU'S Exam Prep app. You can take the screenshot of this. This is useful for you. Then students, you can see GATE Super 11 series. So top 11 questions for from every subject for the branches electrical, EC, instrumentation and computer science. And the series, top 11 question series, is starting from 27th of Jan. Just book your calendar for this. Students, GATE 2023 exam analysis will be on 4th and 5th Feb, 1 p.m. and 6 p.m. Yes, note down this timetable. So just after your GATE exam, you can take the advantage of this session. So here comes the question from type 3. So students, in this equation, you can see P, Q, X and Y. Before that, see here, as far as the derivatives are concerned, only P and Q are there. As far as the derivatives are concerned, only P and Q are there. Sirf P or Q hai. Only P and Q are there. Correct? Only P and Q are there. So this is first order. But what is the degree of P and Q? What is the degree of P and Q? Degree of P and Q is other than 1. So this is non-linear. First order non-linear. Now, it is having 4 parameters P, Q, X, Y. So this is type 3. This is type 3. This is type 3. So for type 3, how can you proceed for the solution? For type 3, we have this format f of x comma p, f of y comma q equal to k. So students, x is brought to the left hand side and q square is brought to the other side. Comfortable? क्या हम ऐसा कर सकते हैं? Can we do like this? P square minus x and y minus q square. So students, this is p square minus x, y minus q square equal to. Student, this is our elementary equation. Now we will consider this. We'll just equate this with k. So you need to find out p from here. Q square will be y minus k. So p will be root of x plus k and q will be root of y minus k. Comfortable till this point? P will be root of x plus k and q will be root of y minus k. Now, solution. Solution is z equal to integration of p dx, integration of q dy equal to c. What is p? P is root of x plus k. What is q? Root of y minus k. Now, integrate this. Integration of x plus k. Already this is power 1 by 2. So it is power 3 by 2 upon 3 by 2. And this will be also 3 by 2 upon 3 by 2. Plus some constant c. You can just simplify. So 2 by 3 x plus k to the power 3 by 2 and 2 by 3 y minus k to the power 3 by 2 plus c. This is the final answer. And in this question, I want you to approach for type 3. Identify type 3 and solve type. Muhammad Anas will plan and let you know in the Telegram group. Okay, what is your branch? Type 4. Type 4. Type 4. In type 4, nonlinear. Type 4 is also the part of first order nonlinear P.D.E. Here, the format is named as Clairaut's form. It is Z equal to Px plus Qy, Px plus Qy and f of p comma q. And students, believe me, this is the simplest. This is the simplest. If you just identify it within 1 second, you can write the solution. See its general solution. General solution is P is replaced by A, Q is replaced by B, f of A comma B. That's it. This is Clairaut's form. This is Clairaut's form. Done. Hello. See this question. All of you must go through this question. Z equal to Px plus Qy plus under root of this. What we want? We want its solution. Very simple. This is Clairaut's form, na? Type 4. Z equal to Px plus Qy plus f of p comma q. So what is its general solution? Ax plus by plus root of 1 plus a square plus b square. That's it. Just you need to replace p by a and q by b. This is the beauty of type 4. Type 4 is also non-linear, first order non-linear P.D.E. Now see this question. Just simplify this. So P, here, this bracket as it is, Z minus Px minus Qy and 1 upon this P minus Q. Now Px and Qy brought to the other side. So this is again Clairaut's form. So its general solution is Ax plus By plus 1 upon A minus B. That's it. Comfortable everyone? So students, till this point of time, we have covered the first order linear as well as first order non-linear P.D.Es. Now, one very important variety from partial differential equation is type identification. Type identification of second order partial differential equation. Okay, so students, just have a look over this. Now see here, this is second order partial differential equation. A, del square u by del x square. B, del square u by del x del y. C, del square u by del y square. Then there are two first order terms, then fu and g. There may be some other functions, but these three terms, that is second order derivative terms, will decide the type of the second order PD. These three terms will decide the type of second order PD. Okay. So del square u by del x square, its coefficient is a. Del square u by del x square, del square u by del x del y, its coefficient is b, and del square u by del y square, its coefficient is c. So you have to compare the given second order PDE with this format, and you need to find out the values of a, b and c. After finding out a, b and c, you need to find out this b square minus 4ac. b square minus 4ac. So if this b square minus 4ac is less than 0, then type of equation is elliptic equation. Elliptic. So solution curve will be an ellipse. Leave it. Just remember elliptic equation. If b square minus 4ac is 0, then type of equation will be parabolic equation. And third possibility, when b square minus 4ac is greater than 0, then go for hyperbolic equation. Okay, so b square minus 4ac has got three possibilities. B square minus 4ac has got three possibilities: less than 0, equal to 0, and greater than 0. For less than 0, you have elliptic equation. For equal to 0, you have parabolic equation. And for greater than 0, you have hyperbolic equation. Still, students may be confused in the exam. To avoid that confusion, okay, see here. When we draw a number line, there is a 0. Then further we have less than 0 and greater than 0. Further we have less than 0 and greater than 0. Okay, understood? So equal to 0, less than 0 and greater than 0. Equal to 0, greater than 0 and less than 0. So have I placed these values correctly? See, on the number line there is a 0. Okay, on the left side of 0 you have negative values. On the right side of 0 you have positive values. Correct? So this number line is tracking what? This number line is tracking b square minus 4ac. This number line is tracking b square minus 4ac. So see here, b square minus 4ac, if it is 0, then you say parabolic solution or parabolic equation. B square minus 4ac, if it is less than 0, then it is elliptic equation. And b square minus 4ac, if it is greater than 0, it is hyperbolic equation. So students, just remember this sequence: E, P, H. E for less than 0, P for equal to 0, and H for greater than equal to 0, greater than 0. Okay, so whenever we are tensed, we say oof. Whenever we are tensed, we are troubled, we say oof. But this time you have to say if, EPH, if. Okay, so E stands for, E will come first, that is elliptic, less than 0, then P, parabolic, then H means hyperbolic. So less than 0, equal to 0, and greater than 0, this is the sequence. Then you can remember the sequence EPH. That's it. Now see this. The type of partial equation, partial differential equation. This is second order derivative term. This is also second order. This is also second order. Okay. So del square p by del x square will give you a. Del square p by del y square will give you c. And del square p by del x del y will give you b. Okay. Yes. So students, just calculate b square minus 4ac. See here, b square minus 4ac is 5, which is greater than 0. I just remember that sequence EPH. So greater than 0 means hyperbolic. So option C is the correct answer. Option C is the correct answer. Comfortable? Then next. Yes, Natu. Natu. Next. See this equation. This equation has got only one second order derivative term. This is not second order derivative. So here A is 1, but B and C terms are absent. So 0. B square. B square minus 4ac 0. EPH. Middle one is 0. Parabolic. क्या हो गया भाई, गलत हो गया क्या? EPH 0 for parabolic ना, 0 for parabolic. Elliptical means negative, that's why E is coming first. See, 0, less than 0, greater than 0. EPH. So 0 means parabolic. Next. See here. This is one dimensional heat equation. Come on, fast. This is not second order derivative. This is second order derivative. So here A is 1. Same question. B and C both are 0. So this is the format for one dimensional heat equation. This is the format for one dimensional heat equation. Okay. So B square minus 4AC will be 0. So it will be parabolic equation. If someone asks you, directly they can ask you what is the type of equation, what is the type of one dimensional heat equation. One dimensional heat equation is parabolic. Yes, what about others? Keep on hitting the like button. Let's proceed. See, this is Laplace equation. No, this is not Laplace equation. In Laplace equation, right hand side is 0. So this is similar to Laplace equation. Del square u by del x square plus del square u by del y square. So these both are the second order derivative terms. So value of A is 1. Del square u by del x del y is absent. So B is 0 and C is 1. B square minus 4AC. Less than 0. Less than 0 means elliptic, first one. elliptic equation. Next. Next is the method of separation of variables. Method of separation of variables. Method of separation of variables. Okay. So we will learn this method and then we'll move towards the application part. That's great, Tatu. So students, before solving this, I am just requesting a 1 minute time from all of you. I'll be right back in 1 minute. Just keep on. Just try this, but I will be definitely explaining the entire solution. Give me 1 minute. So students, I will explain you method of separation of variables, and this particular method is useful for developing the solution of for developing the solution of for developing the solution of application based questions. Okay, so students, just concentrate. See, using the method of separation of variables, solve this del u by del x equal to 2 times del u by del t plus u. Now, at this point of time, stop thinking like whether this will be in gate or not. Just give me a free hand to explain the concept. Just I need 15 minutes from your side. Okay. Yes, stay tuned. Student, see here. In this equation, the variable present in the numerator is u and variable present in denominator is x and t. So we can clearly say that okay, what I will do, I will just note down this equation once. मैं एक बार इस equation को लिख लेता हूँ. So del u by del x equal to 2 times del u by del t plus u. This is my given equation. Now in this given equation, or by observing this given equation, we can say that u is the function of x and t. Here u is the function of x and t. Okay, so what we are doing, we are assuming u to be the product of capital X and capital T. We are assuming U to be the product of capital X and capital T. Now what is this capital X and capital T? Capital X is function of small x only and capital T is function of small t only. Okay. Now from this relation I will be calculating del u by del x and del u by del t. Friends, u equal to x into t, u equal to x into t. I want del u by del x. So when I take partial derivative with respect to x, then capital X derivative will be x dash and t will remain as it is. When I take partial derivative with respect to t, capital X will remain as it is and derivative of t will be denoted by t dash. Okay ji? Yes sir. Now what to do? Now we will be putting these derivatives in equation number 1. तो del u by del x के स्थान पर कैपिटल x dash t, then 2 times del u by del t. Del u by del t is x t dash, g sir, and u is x into t. Comfortable with this? Yes sir. So del u by del x is x dash t, 2xt dash plus x into t. Now I will hide myself once again. I will come back on the screen. Now see here, on right hand side what you are doing, x dash t, capital X common, 2t dash plus t. So x dash upon x and 2t dash plus t upon t. This is my equation 1. I hope you all have understood till this point. Now what I will do, I will just equate this ratio to k. So what we have done till this point, हमने क्या किया यहाँ तक? We have just separated the variables. So terms of x on one side, terms containing t here and constant term on the right hand side. So this is how we have separated the variables. Now I am going to consider x dash upon x equal to k. I am going to consider one ratio. Okay, yes sir. So students, 1 upon capital X aside, x dash is dx upon d small x. This is the value of x dash equal to k. Now dx upon capital X equal to k dx. Now integrate both sides. So integration of dx by x, integration of k dx. Very nice sir, very nice, super. Now students see here, integration of 1 by x, log of capital X, k constant, integration of 1 will be small x plus some constant. So intentionally we are adding a constant log c1. Okay, we are adding a constant log c1. Now what happens students, log terms are accumulated together on the left hand side. Log की terms को left hand side पर ले गए. Log x minus log c1 will be log x by c1 and right hand side is kx. If you take anti-log, so you will get x upon c1, and right hand side will be e to the power kx. So capital X will be finally c1 e raised to kx. Now you tell me, how many of you understood this? किसको किसको समझ में आ गया? So we have got one solution. This is equation number 4. We have got one solution. Okay. Yes, sir. No. Now we will consider another set. Now we will consider another set. Another set is 2t dash plus t upon t equal to k. Now separate this. इसको अलग अलग कर लो. Here 2 t dash upon t upon t will be 1 equal to k. So t dash upon t will be k minus 1 upon 2. T dash upon t will be k minus 1 upon 2. So 1 by t, and t dash is dt upon d small t. Now separate the variables. So dt upon t equal to k minus 1 by 2 into dt. Integrate both sides. So integration of dt by t is log t. K minus 1 by 2. K minus 1 by 2. Integration of 1 will be t plus some constant c2. In fact, we will be adding log c2. Log c2. So log t minus log c2. Log t by c2. K minus 1 by 2 into t. Taking anti-log. Taking anti-log. Taking anti-log. Taking anti-log. Taking anti-log. So t will be t by c2 will be e to the power k minus 1 by 2 into t, and this c2 is cross multiplied here. Students, we have got x and t. We have got x and t. I'll just show you the entire solution till now. This is the first frame. In the first frame, see this equation number 2. In this equation 2, u is equal to x into t. You obtain x and t separately. Now see here. U is nothing but the function of x and t. U is the function of small x and small t, which is capital X into capital T. Capital X is c1 e raised to kx. Into capital T. Capital T is c2 e raised to k minus 1 by 2 into t. Like this. Now students, what we can do here? C1 and C2 is replaced by a single constant C. E to the power. Powers will be added. So kx plus k minus 1 by 2 into t. So we have obtained the general solution. This is my equation number 6. Okay, we have got the general solution. Now, what they mentioned in the initial condition, u of x comma 0 is 6 e raised to minus 3x. You can mention here that what is C? C is C1, C2. C is C1, C2. C is C1, C2. Okay. Yes. Then what we can do? Given A. What is given? U of x comma 0. U of x comma 0 is 6 e raised to minus 3x. Okay. Now what you can do? What you have to do? You have to put, see, x comma t, t equal to 0. Put t equal to 0 in equation 6. So equation 6 will be u of x comma 0 c e raised to kx, u of x comma t is 0, c as it is, e raised to kx, and t is 0. So you have got this one, and already they mentioned that it is 6 e raised to minus 3x. So on comparing both sides, we get c equal to 6 and k equal to 3. After getting this value of 6, c and k, put them in equation number 6. So ux comma t, c is nothing but 6, e raised to kx, k is 3, k is 3, k is minus 3, k is minus 3 bhai, k is minus 3, that was my mistake, k is minus 3, yes. So 6 e raised to minus 3x, then minus 3 minus 1, minus 3 minus 1, minus 4, minus 4 by 2, minus 2t. So this is the required solution. You may be thinking, why too lengthy? But this is the platform for generating solutions for applications of partial differential equation. Application of P.D.E is dependent on this method, and that's why it is necessary to learn this. So I have shown you the entire method with the help of this beautiful example. Now, before moving to the next, I just request all of you to have a look over this entire question. I'm just hiding myself so that you can take the screenshots if you want. Anyways, I will be giving the PDF in my Telegram group. Yes, this is the first frame. This is the second frame. Once again, first frame 1, 2, 3, 4, 5. Next, second frame 1, 2, 3, 4, 5. Next. So this is the final solution frame. So I hope you all have got the confidence to solve this. But I need your response in the comment box in the form of hearts, in the form of some bonfire. Come on. Great. Krishnaveni, Pratmesh, Rohit Pandey, Madhi Boina, Sisindri. Now, you tell me, can you solve this question? Will you try this question? How many of you in this session have the courage of responding that they can solve this? I'm just putting this as homework for you. I have got some responses. Yes, Mohammed Anas, we will plan complex variable, and regarding the exact schedule, you will get the information in the Telegram group. Great. Now, here is the heat equation. Now, we will develop a general solution for heat equation now. We will develop a general solution. Yes, I request all of you to join my Telegram group. I'll share the link in the Telegram. I'll just share the link of the Telegram group in the comment box. Yes. Next. So now we are going to observe the heat equation. Heat equation. Students, when we talk about the heat equation, see here, U is U is U is the function of x and t. Okay. So we are assuming U equal to x into t. Let us say this is first equation, this is second equation. Now, del U by del t will be x t dash. Del U by del t will be x t dash. Yes, come on. Equal to c square. Del square U by del x square. Double derivative with respect to x. This will be x double dash t. Okay, and this is equal to k. Just a moment, we'll separate the variables first. So t dash by t, t dash by t. So c square x double dash upon x t dash by t c square x double dash upon x equal to k. Correct? Got it? Now see here. We will consider two parts, t dash by t equal to k. So t dash by t equal to k. T dash by t equal to k. 1 by t dt by d small t equal to dk. Okay. So dt by t equal to, right hand side is only k. Dt by capital T equal to k dt. Then integrate both sides. So log t equal to kt plus some constant log c1. Okay, sir. So log t minus log c1 will be t upon c1. It is e raised to kt. So t will be c1 times e raised to kt. Comfortable? Now see the another part. C square x double dash upon x equal to k. Do one thing. Just a moment. Nothing wrong in this, but to match the exact solution, I'm doing little change here. Nothing wrong in this, huh? But to get the exact format mentioned in the bookish language, I'm just bringing this. See here. Please concentrate. X double dash upon x. This will be x double dash upon x. This will be t dash upon t 1 by c square. Is that clear? Dash, right? And x t, that is also correct, equal to k. This is the equation after separation of variables. After separation of variables, we got this one. Now consider x dash upon x equal to k. Okay. Now see here, x double dash equal to kx. X double dash is t square x upon tx square and kx. Okay. Now bring this kx to the left hand side. Bring this kx to the left hand side. Okay, we got this one. Now students, please concentrate. See here, k can be, I am assuming k, for simplification I am assuming this k, for simplification I am assuming this k to be second degree variable. Just a moment, I am just assuming k equal to what? K equal to what? K equal to plus p square. If I write k equal to plus p square, then I will get d square x upon dx square minus p square x equal to 0. See, what we are doing, we are putting k equal to p square. So d square x upon dx square minus k is p square. So p square x equal to 0. Now, if I put k equal to minus p square, then I will get a slight change in the equation. D square x upon dx square plus p square x equal to 0. Okay. Now, d by dx is capital D. Capital X is common. Capital D. So d square plus p square, capital X is common. Okay. Now students, this is a constant coefficient LDE. This is also a constant coefficient LDE. So their solution is CS equal to CF plus PI. But right hand side is 0, so PI will be 0. So complete solution will be only CF. We just write the auxiliary equation. M square minus P square equal to 0. M equal to plus minus p, and here m square plus p square equal to 0, so m equal to 0 plus minus pi, m equal to 0 plus minus pi. Comfortable? Sir, why you are doing in two different ways? Anyways, I am going to reject one solution, but I can just show you the two possibilities. So complete solution will be only CF. Complete solution is denoted by dependent variable. Here dependent variable is x. C1 e raised to px and C2 e raised to minus px. This is one way. Another way, complete solution is equal to only CF capital X equal to this is imaginary roots. So alpha is 0, beta is p. So C1 cos px and C2 sin px. Understood these two ways? Okay, sir. Now this is okay. Now we will solve the another part. I will solve the another part. Another part is 1 by c square t dash by t equal to k. Okay, sir. So 1 by t is out. T dash means dt upon d small t equal to c square k. So dt upon capital T equal to c square k dt. Integrate both sides. So log t. Students, stay tuned here. C square k integration of dt will be t. Okay. Plus some constant log c t. So t by c3 equal to e raised to c square kt. Very good. So t will be c3 e raised to c square kt. This is the, now what is our k? K can be minus p square and plus p square. If k is plus p square, then t will be c3 e raised to c square p square t. And if k is minus p square, then t will be c3 e raised to minus c square p square t. Correct? So these are the two possibilities. Now see here, out of these two, with respect to time t, this is exponentially increasing, and with respect to time t, this is exponentially decreasing. So this exponential decrease or decrease with respect to time t is in accordance with Newton's law of cooling. So heat equation satisfies this one. But what this is saying, that as time increases, temperature goes on increasing. So this is not in accordance with the law of conservation of energy. So we rejected this solution because the physical scenario is not allowing us to do this. So ultimately, you need to consider that solution which is corresponding to k equal to minus p square. Here and on the previous slide also. So k equal to minus p square. This solution is selected. This one is rejected. Okay, understood? So we need to select the solution corresponding to k equal to minus p square. We know that u equal to x into t. U equal to x into t. U is nothing but the function of x and t. What is capital X? Capital X is C1 cos Px plus C2 sin Px. And what is capital T? C3 e raised to minus C square P square T. Now students, please concentrate. Students are not finding it interesting. Oh, anyways, it's your choice. See, but you will not find this content once again. C1 C3, C1 C3, C1 C3, cos and exponential. Okay. So C1 into C3 is replaced by a new constant capital C1 cos Px. C2 C3, C2 C3, C2 C3, capital C2 sin Px e to the power minus C square P square T. Bachcho, this is the general solution for heat equation. This is the general solution for heat equation. Now we will apply this concept to solve some question. See here. Given a del u by del t equal to del square u by del x square. If you compare this with heat equation, del u by del t equal to c square del square u by del x square, you will get c square equal to 1. See this, you will get c square equal to 1. Now see here, this equation, they have given some what we say, the boundary conditions. Boundary conditions u of 0 comma t equal to 0 and u of 1 comma t is also 0. Okay, and x is under the range 0 to 1. X is varying in the interval 0 to 1. So at x equal to 0, u is 0. At x equal to 1, upper bound, u is also 0. Now initial conditions, this is related with time. U of x comma 0 is, the time variable is 0. So you are getting 3 sine. Understood? These are the given conditions. Now what is the general solution you derived now? U of x comma t equal to capital C1 cos px, capital C2 sin px, and here you have e to the power minus c square p square t, but c square is already 1. C square is already 1. So you will get ux comma t c1 cos px, c2 sin px, e to the power minus c square is 1 p square t, equation number 1. So this is our general solution. we will be applying boundary conditions and further initial condition to find the values of C2 and P. That will be your final answer. Okay, and these are gate questions, students, don't worry. Okay, now see here, boundary condition. Boundary conditions. Boundary conditions. U of 0 comma t equal to 0. It means x is 0. रख दीजिए. Put x equal to 0 here. Put x equal to 0 in equation 1. So u of 0 comma t. हाँ, x is 0 ना. तो cos 0 भाई 1 होता है. Cos 0 is 1. Sin 0 is 0. E to the power minus p square t. Now this is given as 0. This is given as 0. So students, ultimately what you are getting, see, C1 e to the power minus p square t equal to 0. Now student, the product of these two quantities is 0. This exponential term cannot be 0. It means C1 should be 0 to satisfy this equation. Put this C1 in equation 1. So you will get a compact solution. C1 is 0. So first term will vanish. You will get C2 sin px, C2 sin px e to the power minus p square t. This is my equation number 2. Now in this equation we are going to apply the second condition. What is the second condition? Second condition is u of 1 comma t equal to 0. It means you have to put x equal to 1. Equation 2. X equal to 1. So u of 1 comma t, x equal to 1. So C2 x is 1. So sin p e to the power minus p square t. Now see here, students, this quantity after putting x equal to 1, this is also 0. This boundary condition is also 0. Now concentrate here. C2 cannot be 0 because if C2 becomes 0, this solution will be 0, will become 0. Exponential term cannot be 0. Again, the same reason. Otherwise, the entire solution will become 0. It means we have only one possibility. Sin p is 0. For the equation sin p equal to 0, what is the general solution? General solution will be p equal to n pi. General solution will be p equal to n pi. Comfortable? P equal to n pi. P equal to n pi. So we are putting this value of p in equation number 2. So equation number 2 I will show you once again. See, this is equation 2. So we have got u of x comma t equal to C2 sin, what is p? P is n pi. So n pi x e to the power minus p square t. Let us say this is our equation number 3. Our equation number 3. Comfortable? Okay. Now what? Now in this condition, what we will do? We will apply the third condition. But before applying the third condition, I am just reconsidering this u of x comma t. I am just writing this in a summation, believing that there may be more than one terms. This is in accordance with the concept of Fourier series. And see, this C2 is replaced by a constant Bn. Then we have sin in pi x e minus p squared. In this equation, I am going to apply the initial condition. Initial condition is u of x comma 0 equal to 3 sin pi x. Put t equal to 0. When you put t equal to 0, this term e raised to 0 will be 1, and they have given you this initial condition. This initial condition is 3 sin pi x. 3 sin pi x. On comparing both sides, we can say that this summation will be opened up into a single term only. This right hand side is suggesting us that there is only one term. So only one term means n equal to 1. So b1 sin pi x. Only one term on the right hand side means left hand side is also having only one term. So b1 sin pi x, put n equal to 1. On comparing both sides, you will get b1 equal to 3. Okay. So b1 is 3, n is 1, and this equation 4 is having only one term. So u x comma t, ux comma t equal to bn. What is bn? This is b1 sin n is 1, so sin pi x e to the power minus what is this p? P is n square pi square na. P is n square pi square. P is n pi, already we obtained, and n is 1, so pi square t. Now here put the value of b1. That's it. So u of x comma t, b1 is 3 sin pi x e to the power minus pi square t. This is the final answer. Okay, this is the net particular solution for the given differential equation, and this is Ankit Joshi. And these are my students who have this much of patience to learn this. So students, you have done miracle. If you have the patience, then only you can learn this, otherwise not. Just have a look over this. Just have a look over this. So, do you want to try this? This can be homework for you. This question can be homework for you. Here, value of c is not given, so in your answer, c will be appearing. Okay. Yes. What about this one? We will solve it little bit quickly. See, here c square is 2. So I am writing the general solution. C1 इसी ब्रांच में सबसे टफ मैथ्स आता है बेटा. C1 cos px plus C2 sin px and e to the power minus c square p square t. C square is 2. P square t. This is my equation 1. Now I am applying first condition. What is the first condition? U of 0 comma t equal to 0. So I am putting x equal to 0. So C1 cos 0, C2 sin 0 is 0, e to the power minus e to the power minus 2 p square t. Okay. Now this value is given as 0. It means what? It means C1 should be 0. Put this in equation 1. C1 is 0. So we are getting this equation 1 in compact form now. C1 is 0. So C2 sin px e to the power minus 2 p square t. This is my equation 2. Now I am again putting one more initial condition. See here. U of pi comma t is 0. So put x equal to pi. C2 sin p pi e to the power minus 2 p square t equal to 0. Now see, this is 0. C2 cannot be 0, exponential cannot be 0. Otherwise the entire solution will become 0. So sin p pi sin p pi will be 0. If sin p pi is 0, it means p pi, this angle will be n pi. So p will be equal to n. P will be equal to n. P will be equal to n. If you put p equal to n in equation 2, what you are getting? Ux comma t C2 p is n, so sin n pi, sin should be sin n pi. अरे भाई p is n ना, so sin nx, sin nx, then e to the power minus 2 p is n, n square t. कंफर्टेबल? यहां तक समझ में आई बात? This is my equation number 3. I will just come back on the screen. Ux comma c2 sin nx into e raised to the power minus 2 n square t. Now just observe the initial conditions. These initial conditions with respect to time t is having two terms. It means what? It means this right hand side will be having two terms. Okay, so this equation 3 I am rewriting. First term is b1, b1 in place of c2 I am writing b1. No, I should not do this. I should write bn, then sin nx, then exponential, and then I need to put a summation here. Okay, this is my modified equation 3, that is equation 4. Now here I am putting t equal to 0. So u of x comma 0, this will be summation n equal to 1 to infinity dn sin nx e to the power minus 2n squared t, and this will be this is given as sin x plus 2 sin 4x. This is given as sin x plus 2 sin 4x. Comfortable? It means this left hand side summation, should be split into two terms. You substituted t equal to 0, so e raised to 0 हो गया 1. E raised to 0 is 1, and right hand side is sin x plus 2 sin 4x. Just 5 more minutes, students. 5 more minutes. I will be winding up. Stay tuned. The major concept is here now. Now see here. Right hand side is having two terms. It means this left hand side should be split into two terms. So n is equal to 1 and n is equal to 1 and n is equal to 4. So b1 sin x and b4 sin 4x. Now comparing both sides, b1 is equal to 1, n is equal to 1, and then b4 is equal to 2. Okay, for the second part n is 4. Okay, so there are two values of n, 1 and 4. b1 is 1 and b4 is 2. Now equation 4 is giving me the final answer. Now see, of x comma t, one term will be b1, so b1 sin x e to the power, put n equal to 1, e to the power minus 2t, then b4 sin 4x e to the power, 4 square is 16, 16 2s are 32, minus 32t. Correct? So u of x comma t, what is b1 and b4? Tell me. b1 is 1, b4 is 2. So this is the general solution. Now you want something. What is that something? See, we want this one, u of pi by 2 comma log 5. It means x is pi by 2 and t is log 5. So sin pi by 2 is 1, e to the power minus 2 log 5. 2 sin 2. Sin 4 pi by 2 is sin 2 pi, that is 0. So this entire term will vanish. So e to the power log 5 to the power minus 2. So 5 to the power minus 2 means 1 by 25. Tan. 2 of pi by 2 comma log 5 is 1 by 25. 1 by 25 क्या कोई option है? Is there any such option? Yes. This is a gate question. Now you may be thinking, yes, these questions may be there. Yes. So students, 1 by 25 is my answer. I should not say you would have enjoyed this. I should say you would have learned this for the first time. So students, I must say I should stop now, and let's stop. Thanks a lot for being with me. You can just go through the entire solution. PDF will be, I will provide the PDF in my Telegram group. Telegram group link is already shared here. Just a moment. So Telegram link is there in the comment box. Student, GATE and ESC test series full length mock subjects. The link is given in the description box. These are the various features of the test series. Many tests curated by GATE experts. Detailed mock analysis there. You have the utility of using virtual calculator. 4000 plus practice questions are there. A lot many features. Student, don't forget to subscribe our channel. Okay, if you have not done so, download the BYJU'S Exam Prep app. So ensure subscribing our app, like, and selecting the bell icon. Yes, students, thanks a lot. Thanks a lot for being with me. Thank you all. Love you all. Take care. Stay happy. Stay safe. Wish you all the best for your upcoming GATE exam. Thank you. I hope you would have enjoyed this. Let's end this session with a very positive vibes in the comment box. फटाफट अपना response add कर दीजिए comment box में. Good night. चलिए, let's stop. Thank you. जय हिंद, जय भारत. I have given you one question. You can post your answers in the comment box.